we have, what is the Lewis structure for TeF4? Well, I mean, unfortunately, we have the answer right there, but I'm still going to describe it. So, Lewis for TeF4. So if we can just ignore that answer right there staring at our face, because that is drawn quite big, we're still going to go through the periodic table and see how we got that Lewis structure to begin with. So tellurium, which is Te right here, is on the 16th column. So we're going to assume that it has 6 valence electrons. And fluorine is on the 17th column. So each fluorine will be having 7 valence electrons. So that's 28 in total. And 28 plus 6 should equal 34 theoretically. So we have 34 electrons to distribute. Considering that tellurium is the only unique one, that's what we're going to put in the middle. So we have Te. I can tell you right now, this is most likely going to break the octet rule, because just like oxygen, typically all it needs is 2 bonds to be able to fill its octet, but now it has to deal with 4 bonds. So something is definitely not right here. So we're going to have 1, 2, 3, 4. And now we're going to fill the octet for the fluorines first. So each fluorine right now is sharing 1 of its 7. So it's going to be 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And 2, 3, 4, 5, 6, 7. So there we go. We have fluorine complete. Now tellurium, as it says, definitely going to have an expanded octet rule, because right now it's sharing 4 of its 6. So really we need to add a 5 and a 6, which is what we're going to do. 5, 6. 1 lone pair for tellurium. So with that being said, do we have 34 electrons total? Well, let's check. We have 4 bonds, so that's 8 electrons so far. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lone pairs. So that's 26 electrons again. So 26 plus 8, hopefully we also do get 34. So this actually has the right amount of electrons. Now, are the formal charges all 0? Let's find out. For fluorine, the formal charge should be 0. We just need 3 lone pairs, 1 bond. And there you have it. That will be the formal charge for fluorine. It is indeed 0. For tellurium, on the other hand, this is a little bit tricky. If we're assuming it works like oxygen, it should actually just have 2 lone pairs and 2 bonds. But the interesting and cool thing is that you actually turn a lone pair into a bond each, as in 1 lone pair will produce 2 bonds, and you would still keep with the same formal charge of 0. So if we did like this, now we have 4 bonds and 1 lone pair, which is, funny enough, exactly what tellurium has. So tellurium also has a formal charge of 0. And with that being said, we verified the electrons, the formal charges, and we had to expand the octet for tellurium, but this will be the Lewis structure for tellurium tetrafluoride. And let's see, as we saw here in this picture, that is exactly what we get. So this is correct. And now we move on to question number 14.